To give us a little bit more understanding about the laws of physics regarding gravity here, we're going to calculate the force between the Earth and the Moon and the force between the Earth and the Sun. And let's see what we end up with. Well, here's the equation. F equals g m1 m2 divided by the distance between them squared. So let's start with the Earth and the Moon. And so the equation would then read F is equal to g small m big M divided by the distance between them squared. Now small m would be the mass of the Moon, big M would be the mass of the Earth. Plug in the numbers, we would get 6.67 times 10 to the minus 11 newtons meters squared per kilogram squared. Of course, remember that whenever we have a constant, so that we can make an equation, the units of the constant always are such that they come out to the correct unit for the variable you're looking for. In this case, we're looking for newtons, so the meter squared and kilogram squared cancel out the kilogram squared here and the meter squared down there. All right, the mass of the Moon, that would be 7.36 times 10 to the 22 kilograms. And the mass of the Earth, that would be 5.98 times 10 to the 24th kilograms. Turns out that the mass of the Moon is about 1/50 the mass of the Earth, roughly speaking. And divide that by the distance between them. The average distance is about 385,000 kilometers, so it would be 385 million meters. And we have to square that. All right, now we're obviously going to need a calculator. Those are quite big numbers, although we used to do that on the slide rule. 6.67 e to the 11, let's do it again, 6.67 e to the 11 minus times 7.36 e to the 22nd times 5.98 e to the 24th and divided by 385 e to the 6th squared equals, and there's the force. It is equal to 1.98 times 10 to the 20th newtons. So that's the force between the Earth and the Moon. That's the force that keeps the Moon in orbit around the Earth. Without it, the Moon would shoot straight, like a straight arrow, into space according to Newton's first law. All objects, unless the force acts upon it, will move in a straight line with a constant velocity. And so, of course, the Moon doesn't do that because the Earth attracts it to the Moon. All right, now let's do the Sun and the Earth, so Earth and Sun. We use the same equation, but now, of course, the big M belongs to the Sun, the small m belongs to the Earth, and what will we get? So the force between those two would be equal to 6.67 times 10 to the minus 11 newtons meters squared per kilogram squared. Multiply that times the mass of the Earth in this case, that would be 5.98 times 10 to the 24th kilograms. Mass of the Sun is approximately 2.0 times 10 to the 30th kilograms. And the whole thing divided by the distance between the Earth and the Sun. Now the average distance is around 149,500,000 kilometers, so 149.5 times 10 to the 6th kilometers times 10 to the 9th meters. And we have to square that. All right, that should give us the force between the Earth and the Sun. So 6.67 e to the 11 minus times 5.98 e to the 24th times 2 e to the 30th divided by 149.5 e to the 9th squared equals, and the force between the Earth and the Sun is 3.57 times 10 to the 22nd newtons. Now look at that. That's roughly, not quite, 100, 200, I think it's like 176 times. So this is 176 times the force between the Earth and the Moon. Well, it takes a lot more force, because the Earth is so much bigger than the Moon, to keep the Earth in orbit around the Sun. And now you may say, well, that seems strange, because tidal forces on the Earth are primarily caused by the Moon and not by the Sun, even though the force between the Earth and the Moon is much weaker than the force between the Sun and the Earth. So say, well, why would the tidal forces therefore be stronger because of the presence of the Moon rather than the presence of the Sun? Well, for that, we have another video waiting for you, not the next one, but some videos further ahead. We will talk about tidal forces and how they're affected by the gravitational force of the moon and the gravitational force of the sun. Here, all we wanted to do here is simply calculate the force between the Earth and the moon and the Earth and the sun, and that's how we do that.